Last video we successfully derived the quadratic formula, and also we know how to use this formula. And this time we are going to analyze this formula because there's something that caught my attention. Now there's a square root inside this formula. Now we know that square root cannot take negative values because it will give us an undefined answer. The reason why it is undefined is because anything squared will give you a positive value or a minimum value of 0. Since square root and squared work in opposite directions, if anything squared cannot give us a negative value, we can't square root a negative value either. So b squared minus 4ac becomes somewhat important. If b squared minus 4ac is negative, we cannot have a value for x. And therefore, we call this b squared minus 4ac as discriminant. And there are three cases here. Discriminant is negative, discriminant is equal to 0, and discriminant is positive. Just like that. Negative equals 0, positive. So what do these do to our quadratic equations then? Well, let's start with the first case. Discriminant is negative. So we will have no values of x. That means the quadratic polynomial is not equal to 0. In terms of graph, that surely means that the quadratic curve will not touch x-axis at all. There is no intersection between x-axis and the curve. Therefore, it looks like this. Now there are two different types of general shapes for a quadratic curve. When a is more than 0, when the coefficient of x squared is positive, it looks like a U shape. When a is less than 0, when a is negative, the coefficient of x squared is negative, it looks like an N shape. So, as you can see here, no intersection between x-axis and the curve. When a is more than 0, this curve is actually above the x-axis. And when a is less than 0, this curve is actually underneath the x-axis. And so for this, there are no real roots because there's no intersection between x-axis and the curve. Now let's look at when discriminant is equal to 0. Well, square root 0 is 0. Plus minus 0 does nothing to the equation. And so we are left with x equal to negative b over 2a. And that means there's only one value of x we can get. Only one intersection between x-axis and the curve. Therefore, the graphs look like this. Only one intersection between x-axis and the curve. And we call these equal roots or one repeated root. Okay, you might wonder, why don't they just call it one root? Because there's only one intersection between x-axis and the curve. Actually, there's a rule that says that the degree of a polynomial determines the number of roots. Degree of a polynomial basically means the highest power of this expression. In this case, the highest power is 2. It's a quadratic equation. So there will be always 2 roots for a quadratic equation. Now you might wonder again, why for when discriminant is negative, there are no real roots? And so where do the 2 roots come from? I can tell you that there are really 2 roots, but they are not real. But for now, just take it as it is, as it will be explained in the later videos. The last case, discriminant is positive. We can square root a positive value, and there's a plus minus, and so we'll have 2 different values for x. And you probably got it right. 2 intersections between x-axis and the curve. Therefore, there are 2 distinct roots, like that. And the roots here are the intersections between x-axis and the parabola, as shown in the red dot. And it's here and here. They are called roots. And so in conclusion, calculating discriminant itself will not give you the exact roots. However, it will tell you the number of roots you are going to get for a quadratic polynomial. So let's see how we can apply discriminant to some questions here. And so let's have the first question, determine number of roots for 4x squared plus 13x plus 11 equals 0. Now we don't want the exact root, we only want how many of roots are there. And so we can just use discriminant. First of all, we can compare ax squared plus bx plus c equals 0 to this quadratic equation. And we know that a is equal to 4, b is equal to 13, and c is equal to 11. So discriminant is b squared minus 4ac, and so we can plug it into discriminant, which is 13 squared minus 4 times a, which is 4, times c, which is 11. 13 squared is 169, minus this is 16 times 11, which is 176. And that will give us, it is negative 7. And this is less than 0. So you can conclude that since b squared minus 4ac is less than 0, is negative, x will not have any value. So there's no real roots for 4x squared plus 13x plus 11 equal to 0. Now let's look at another example here. What about this? Show that x squared plus 7x plus 13 is more than 0 for all values of x. You might want to give it a try, because this is an interesting question. So in this case, we know that the coefficient of x squared is equal to 1, and it is positive. So that means it is a U shape. Okay, so if the curve is above the x-axis, that means there will be no intersection between x-axis and the curve. So it seems like this question wanted us to prove that the discriminant is negative because there are no real roots. It seems like because the curve is above the x-axis, so no real roots. So let's try. So again, this time we are going to compare ax squared plus bx plus c. A is equal to 1, b is equal to 7, and c is equal to 13. And so discriminant, b squared minus 4ac, b is 7, so 7 squared minus 4 times a, which is 1, times c, which is 13, which means that is equal to 49 minus 4 times 13, 52. And that is equal to negative 3. And again, it's less than 0. So if it is less than 0, we can draw a graph. No intersection between x-axis and the curve. And since it is a U shape, it will be something like that. And this is x-axis, this is y-axis. So no intersection between x-axis and the curve. And so first of all, no real roots. And therefore, x squared plus 7x plus 13 is more than 0 because the curve is entirely above the x-axis.